I welcome you all to the next session of revision, review, and recap before the term end. As all of you are aware that the next week there will be our term end exam starting from the 2nd of November. It will last up to 10th of November. For the with respect to for the big data analytics subject, there will be the first four chapter will be there for the exam. We have revised first 2.5 chapter in the last session. Now today we will revise what do we mean by the SQL versus NoSQL, data modeling concept, and CAP theorem. That will be our last revision before the term end. Exam pattern is shared with you that it will be of the 30 marks, 10 marks MCQ, 10 marks short questions, short answers, and 10 marks long answers. That way it will be a 30 marks. It will be in online mode and it will be conducted by using Google Classroom and TestMos most probably. So attendance is mandatory because it will be considered for the concurrent evaluation head. It will be considered as a concurrent evaluation head. So today session we are going to start. Okay, we are going to start with our session of revision. Let me share the screen with you. Today we are going to revise the fourth chapter, that is of data modeling techniques, SQL and NoSQL, acid versus base concept, and what do we mean by the CAP theorem. I hope the screen is visible to all of you. Thank you. Mark your attendance. Yes, now this is the NoSQL databases and NRDBMS concept revision. Now, what do we mean by the RDBMS or data modeling? When we are talking about the data modeling, it is like the relational database management system. All of us knows that there will be the integrity concept, integrity, data integrity, referential integrity, some mapping constraint will be there, and it will be like a relation converted into a tabular format. So today we are going to have the revision of the NoSQL databases and data modeling concept. In the last session, we have taken a revision up to the first third chapter. Today, we are going to visit the data modeling concept again. Now, what do we mean by the data modeling as such? Data modeling is mean nothing but it took just preserving or storing data in a meaningful way by imposing some kind of some kind of the integrity constraint over that, that may be the data integrity, that may be the referential integrity, or that may be the mapping constraint like one to many, many to one, like that. Now it is not the data modeling is only with respect to the NoSQL or NRDBMS or big data analytics. Okay, it is in the RDBMS also. Even actually the RDBMS itself is a data modeling concept because we are converting that given the relationship, that entity relationship diagram, into a tabular diagram or tabular form, and that tabular each entity or each relation represent a table. Each entity will have the table and relation will have the transaction table. That's a master table and transaction table concept is there. And that is nothing but the RDBMS concept, that's a relational database management system. There will be the some attributes per table. Attributes mean the field of that table. Then the number of tuples will be there and name for that particular entity or table will be there. That is nothing but the tabular format of that entity. Means you are representing that entity in a tabular format. That is a simple way of modeling. Okay, we are modeling that data, whatever the data of the entity. In this case, there is a data of course. Okay, then that course data is modeled in a tabular format by having some kind of particular instructions or sorry constraint over that tabular format, that a particular field will be the primary key field, like the course number can be the primary key field. Any particular field will have the not null concept, like the course name should be there, means it should be alphabetic one. That are the some of the constraint. Okay, that is the RDBMS concept. But then why then there are the issues with respect to the RDBMS, means which are the issues? Issues mean the challenges faced by the RDBMS. The first challenge faced by the RDBMS is the scalability. now, what do you mean by the scalabilities? Each RDBMS table, that's an entity, is having the particular schema. Schema means what? You can say the nature of data, format of data, and in the RDBMS, it is a fixed one. You cannot change the tabular format or entity representation in the RDBMS. It is not a flexible one or a volatile one, which might be the requirement of the data, which is not in a structured way, which is might be in a semi-structure or an unstructured way. Then that data is has to be in a, we should have the flexible data or flexible schema. But if that is not the case, then will be the challenges with respect to the RDBMS, that is a scalability. Scalability, that are the 2 points of the scalability are there. Anyone is not true at the RDBMS. 2 point means either it is not vertically scalable or horizontally scalable. Okay, horizontally scalable, it's the meaning of what you can say, it is not having the flexible schema. Horizontal means what? Across the table. Okay, now this is the horizontal: name, course, unit. Suppose these are the three attributes of the any course, and if suppose you wish to add the fourth one during the execution or at the time of compilation or in between at any particular time instance, like suppose the course duration, then it is not possible. That is a horizontal scalability is not possible. Whereas vertical scalability means a number of tuples. Okay, if suppose you are getting the number of tuples from the various data nodes or data sources at a time, that is the concurrent access of that database, then it may not be possible to access that database underlying table concurrently by the all data source. That is a, you can say, the vertical scalability. That is a scalability issue with respect to the RDBMS. That's why it is not, means it is not designed, RDBMS is not designed to be a distributed one. Distributed means across the data nodes or data sources, it cannot be distributed. And even horizontal scaling is not possible. And that's why there comes the concept of the big data or NRDBMS. Okay, these are the scaling challenges or concept with respect to the RDBMS, that master slave, all rights are returned to the master and all the reads are performed against that replicated slave. And data sharding, that we have seen that data sharding, that the number of nodes, the data source can be there, and that can access that underlying table simultaneously. That is a data sharding concept. You can have that data is non-transparent, can no longer have the relationship or joins across the partition, because if the data is partition, obviously you cannot have the joins or relationships possible across the tables. Then obviously there will be the loss of referential integrity across the shards. Shard is what? A data partition. Means suppose you are getting a data from number of sources, then for the source number one, there can be a data partition number one, then two, then data partition number two. That's way it can be done. And then there comes the NoSQL. To overcome such a challenges under the RDBMS, there is the rise of NoSQL. NoSQL databases means what? Not only SQL, means it is not only a structured one. You can store the semi-structured or unstructured data also, which are not following the ACID properties as it is or cent percent, like the data generated. Many times you have discussed that social media data or live video streaming data, and that's way we can perform the data, or you can perform the NoSQL or NRDBMS databases. Then it is do not require have to have the fixed table schema. As like in the RDBMS, there is a fixed table schema. But in a NoSQL, there is no as such fixed table schema, and also there will be relaxation for the acid property. Acid means what? Atomicity, consistency, and isolation and durability. Any RDBMS like Oracle, MS SQL, PostgreSQL, MS Access shall follow the acid property. Okay, but NoSQL like databases like MongoDB, CouchDB, Cassandra, they will not follow NoSQL in a same percent way. See the wording is relaxation for one or more of the acid property. Okay, means either of these four will not be there. Okay, at least any one of these will not be there, and that will be using it can be done by using the CAP theorem. That is a CAP. CAP means consistency, availability, and partition. That is a CAP or CAP theorem, which is also called as the Breuer's theorem. These are the some of the examples of the RDBMS and NoSQL. Out of that, we are currently next our session will be on the Hadoop. That will give you the more idea about the Hadoop framework. Now, what are the pros and cons of the NoSQL? Now, why I have chosen this particular topic for the revision or review? Because if you are gone through the question bank, जो मैंने आपको I have provided you at your Google Classroom, which is a compilation of the last 5 years university paper. If you are gone through, then you might have aware and understood that there are many up to the 30 to 40% questions are based on the such a concept of the NoSQL. What do you mean by the data modeling? What are the acid and base concept? That's why I have chosen this particular topic for the revision or revise. Now, what are the pros of the SQL? That the structured data, obviously it's a SQL, that's why it will be a structured data. Then transactionally high performance workload are good at the relational database because it is being accessed by the structured way. That's why obviously the transactions can be done in a various sorry for interruption, in the various efficient way, and that's why it will be possible to have the transactional high performance. Cons means the negative points. Very first, that's the fixed schema. It is not having the any flexible or volatile schema. It is a fixed one, prefix you can say. If data is used for the transaction, then it is difficult to scale. These are some of the negative points. Examples, all of us know that the Oracle, Sybase, DBase, PostgreSQL, SQL Server, etc. These are the MS Access. These are the examples of the SQL. Coming back to the NoSQL, the main positive point of the NoSQL system are that they are useful when the working with the huge quantity of data. That is a big data analytics. For that purpose only, NoSQL has been invented, and they are distributed and non-relational databases. These are the positive points of the any NoSQL database. Then the negative points are the management tools, installation till maturing, because being the open source language or open source platform, it is not having any particular way, authorized way, or you can say SOP or standard way to operate on the NoSQL databases. And that's why it is said that it is still maturing. Millions of users doing updates as well as reads in contrast to the traditional DBMS. Examples like CouchDB, MongoDB, Cassandra, DynamicDB, Google Bigtable, etc. These are the examples of the NoSQL. Obviously, there are some pros and cons of the each system, SQL and NoSQL, but it is not the case that now due to the NoSQL we can replace the SQL. Okay, obviously, if there are the positive points of the SQL on the one side and positive points of the NoSQL on the another side, but SQL cannot be 100% replaced by the NoSQL, because in SQL we are meant for the structured data, whereas NoSQL is meant for the semi-structured or unstructured data. That is a major difference between SQL and NoSQL, or RDBMS and NRDBMS. That's why you have to take into consider that point, and accordingly one system cannot replace the another one. Now this is a cap theorem that any particular time instant at any given particular time there will be any two of the CAP shall be true or shall be valid. That is, a CA stands for consistency, A stands for availability, P stands for the partition or partition tolerance. If either CA, AP or CP will be true at a time. Okay, that's why any system will either be consistent and available, then it will not be partition one. If it is suppose the consistent and partition, then it will not be available. And if suppose it is a partition and available, obviously it will not be consistent one. These are the some of the points with respect to the cap theorem. Now why? Cap theorem is also called as the Brewer's theorem. The scientist, computer science scientist who invented that cap theorem. Now, why there is a need of the noise scale? But obviously, the first point is the explosion of the social media site means the frequency of data generation is high. With the large data needs, there is a requirement of the noise scale because sharding is a problem in that cases. Sharding means what? Partitioning of the data. Then the rise of cloud-based solutions that gives need to the noise scale. Cloud-based solutions such as maybe Amazon or Microsoft Azure like. Then just as moving dynamically typed languages, a shift to dynamically typed data with frequent schema changes, there is a need. Okay, means if you are having the dynamically typed languages, obviously there is a need of dynamically typed data also, and which will have the frequent schema changes, or you can say the flexible schema. Then the expansion of open source community is there. Nowadays, out of 10 software coming daily or in a given time period, out of that, 8 are the open source software or developed or compiled by the open source community. And that's why there is a need of NoSQL. Then the NoSQL solutions are more acceptable to client now than the year ago or previously. Nowadays, more and more clientele is shifting to the NoSQL solution domain. That's why again there is a need of the NoSQL. These are the some types of the NoSQL databases: key value pair, column based, document based, and graph based. These are some of the examples of the key NoSQL databases. What do you mean by the key value pair? It is designed for the processing dictionary. Dictionaries contain the collection of data having the field containing data. And like in a dictionary, अगर आपने इंग्लिश डिक्शनरी कभी देखी या फिर आप एक्सेस करते हैं तो it is placed alphabetically, okay? And that alphabetically again in that word, it is across that word it is alphabetically accessed. That is a key value pair like system. Records are stored and retrieved using a key. That is alphabet is a key in that case that is uniquely identifies the record and is used quickly to find the data within the databases. Okay, that's how that key value pair does work. Examples are the CouchDB, Oracle NoSQL databases, React, etc. Positive point that is in a green color, that's how we use it for the session, storing session information, user profiles, preferences, shopping cart data, etc. And we would avoid it when we need to query a data having a relationship between entities. Column based means every particular data flow will have the column and at every row there will be the column family. Okay, and that is the example like Cassandra, Edgebase, DynamoDB are the examples. We use that particular for the content management system, logging for and log aggregation, and it is not used for the system which are in the early development and changing query patterns. Then it is of no use to use the column-based NoSQL. In a document-based NoSQL, the whole document is stored as a one node, as a one data node, and that whole document store is accessed by using the key value store. Okay, that document store will be given one particular key value, and using that key value, the whole document can be accessed. That is the meaning of document based. Examples are like the Lotus Note, MongoDB, ScoutDB, Raven, etc. It is majorly used for the some of the e-commerce applications. Like if you are having the e-commerce application, आपने देखा है अगर आपको पता है तो like a digital locker is a one of the e-commerce application wherein you are storing all your certificate in that is a document based and even the any particular login like suppose your one bank account अगर अपने ऑनलाइन बैंकिंग यूज करते हैं तो आप वहाँ पे आपका सब स्टोर होता है लास्ट ट्रांजेक्शन डेबिट क्रेडिट सब कुछ वहाँ पे स्टोर होता है एज अ डॉक्यूमेंट then it is the document-based key value or document-based NoSQL in our DBMS system, and it is not being used for the complex transactions spanning multiple operations or queries varying aggregate structure. Then it is not used in such a scenario. If suppose we have to store the graphical data, then the graph-based NoSQL is preferred, wherein we can store the graphical data or a data which can be better represented in a graphical mode, like the social network connected points, spatial data, routing information, like a supply chain management system. Then it will be used or it will use the graph-based NoSQL system, which is having the more graphical interface or graphical representation is more effectively possible. These are the some of the NoSQL based database system. That's the key value, column based, document based, and graph based. Then what do you mean by the CAP theorem? We will with that CAP theorem some of the advantages, and then we will conclude our session. Consistency, availability, partition. We have discussed that the given a time period, we can have most of the two of these properties true for any shared data system. That is either data will be consistent and available, then it will not be partition. Either data will be available and partition, then it will not be consistent. Either data will be available and partition, then it will not be consistent. And every multinational big giant application use the CAP theorem like Google, Yahoo, Facebook, Day, Amazon, eBay, etc. All use the CAP theorem for their big applications. What are the advantages of NoSQL? It is very cheap and easy. Data replicated on multiple nodes, easy to distribute, and don't require any fixed schema. These are some of the advantages of the NoSQL databases. So what is not provided by NoSQL? Joins are not provided, group by functions are not provided. It is not confirmed that they will follow the asset transaction. Better they will follow the base transaction that is basically available and SQL is not provided, that is structured to integration with applications based on the SQL is not provided. Then we have to use NoSQL in such cases wherein we are having the log analysis, social networking fields, time-based data. Then we can use the or very large semi-structured data has to be processed. Then NoSQL is useful. Then to improve the programmer's productivity, it is useful, and also it is useful to improve the data access performance. These are the classification of the NoSQL. We have seen that the graph based, document, key value, and column based. We have discussed all this that how the databases across the NoSQL can be compared with each other across the given features like parameters like design and feature, integrity, indexing, distribution and system programming means by using which language that is being developed. Then such a matrix we can develop that how they can compare with each other. Now that is the percentage that how fastly big data or NoSQL data has been accepted by the multinational companies and big players. And that's why it is now as a conclusion we can say that this Big data or NoSQL pattern is required and it is being classified across the key value, document based and column wide or column based and graph based, graph oriented, and we can evaluate and compare them as per their design, integrity, indexing. That's the last we have seen. This is that design and etc. integrity, distribution and system. That is the, you can say, the comparison point or conclusion point with respect to the NoSQL. This is something review point with respect to the NoSQL databases and data modeling. All choices provided by the rise of NoSQL does not mean the demise of RDBMS. That's what we have discussed, that NoSQL cannot 100% replace the RDBMS. Okay, and because RDBMS is one of the powerful tools and it has its own positive points. While we are entering in the era of polyglot persistence, a technique that uses the different data storage technologies handle the varying data storage needs, and it can apply across the enterprise or within an individual application. These are some of the references for your study purpose. I have forwarded given the all such references at our Google Classroom. So that is something with respect to the revision. Here we conclude our revision session. Thank you.